patching things in the system that will just give you drastically different results. We'll start with really basic stuff right now. What we have here, I'm going to pull it out. You guys might want to get close, and you might want to get close to the camera. Okay, so let's go through what's in the system, first of all. I don't know what's going to end up when or what's going to end up being in here, but some of this will be when they get it. This will be. This is LZX is a company that makes this stuff now. There's a few companies that make things. LZX Brown Shoes only. Dave Jones is making one. These are just, it's the idea of applying oscillators to other oscillators to create, and frequencies and waveforms to create waveforms to create video, to manipulate, well, to generate imagery, actually, synthesize imagery. In this system, this thing called the visual cortex is kind of like the base of how things are happening. So this regulates, this makes that, this device is making sure that these waveforms are being synced to NTSC standard video, so that everything that comes in and comes out is legal video, so you can actually see it on the television. If it wasn't happening, you would have like scrolling or things that were out of sync, or just like garbage kind of in a way. Let me turn this off so you can see this without effects on it. Put that on one. Double check. 1 second, sorry. Change everything around. Garbage. I don't know, I lost sync for a minute, sorry about that. The thing was scrolling out, something was loose.
It looks cool too.
Yeah, it wasn't going to work for our demonstration.
We thought it was totally. We thought you did it on purpose,
Okay, so back to where we were. This device, when it's connected correctly, like it wasn't just now, provides sync to the signal, so it's not scrolling across the screen. So it tells it to start in the top corner and then the bottom. Makes it what we call legal video that can interface with other video, can work in the switcher. It doesn't look all screwed up. This is also comprises of a colorizer here. So what we have in this system is we're working with kind of a component idea. That's why we talked about it earlier. On this channel, it's colorized. This is the luminance channel here. It's the black circle. Luma also there. Red, green, blue. It's an RGB system, actually. The input decoder section, which we're not going to do today, but you could send other video into this and then colorize the video with the synthesizer. which means that you could also drive the colorizer with other oscillators, so you could change the rate of how the colors change according to whatever the frequency is. So this is where you could input video.
So we have the SD,
This is where you output video.
go in SD here,
Yes, it won't take HD. Just SD.
but it could come from there or here and go into
You would need a different kind of inverter. You could get the luminance, you get the black and white. You could colorize that. But to get all the colors, we would have to split this output now into components. You could actually, no, I'm sorry, you could, because the converter will let you do component. And I can show you how to do that if you want to do it. You can do it.
Okay, time out. So the reason it was scrolling is because you hadn't set it up to.
The reason it was scrolling is because something came loose in the sync generator.
In the sync generator.
This is in part of this device called the visual cortex.
Okay. So if you didn't have that thing attached at all and you were just running.
I just ran an oscillator, like tried to run an oscillator in the TV without like turning in illegal video. Yeah, I mean, I wouldn't have that, that's for sure.
It would just move.
Yeah, it wouldn't even look like a circle. It would be like you would see oscillation in the screen, maybe pulsation in the screen, like light and dark, light and dark, light and dark, light and dark.
there.
I mean, I can kind of show you that actually in a way where it's.
So it sort of traps it in the right place, kind of like it says, make your screen happen here.
Okay, so we got these like lines happening. I'm changing the oscillator now. I'm changing the frequency of the oscillator. The range.
Okay.
This is a range knob on the oscillator, and the way they've labeled it is you see 1, 2, horizontal line, and then vertical line. Oh, there's the pedestal. Okay, so horizontal pulsation,
Okay.
much slower pulsation. See that slow? Faster. Make it really fast. As you go faster, you start going into the other. This is like a quick jump. You know, like we go into like groups of frequencies, but essentially it's just spinning this knob more and more and more. So we've now jumped into oscillators. So these are your oscillators.
Sorry, I didn't mean to do that.
Okay, so these are your oscillators. They call it prismatic array. Give it a cute name, but this is a voltage-controlled oscillator. It says it right there.
Prismatic.
Yeah, ray. Yeah, but look at this part. It's really what you want to know is what it actually is. It's a voltage-controlled oscillator. The sync button, if it's okay. So if I bring it to a slower frequency, hit sync.
It's
I
supposed
can.
to try and find.
Yeah, it's going to try to like lock on.
Like tracking on a video.
Yeah, you'll have more stability if you go off sync than it's going. So it's trying to like lock onto the frame rate. So you have these controls. You have the range, which, like I said, is like a quick jump between frequencies. You have the frequency knob itself. I see it's a higher frequency. I get more and more bands. As I go up, as I go down, I get less and less bands. We're changing the length of the wave.
that's
What
something
we're
that-
outputting, what kind of wave we're outputting is, it's a sine wave. So, but if we output a triangle wave, you're not going to see a triangle right like this, but if I modulate another one with it, you would see triangle edges, but you see that the gradation inside is different. Okay, so then we have something called pedestal, which in video, how do I describe pedestal? Pedestal is kind of like a relative level to black, where black is. So the higher the pedestal goes, kind of the brighter the image is. If you go too high on the pedestal, it becomes kind of blown out. And if you go too low on the pedestal, it's too dark. You can't see it. So if we adjust the pedestal, in this case, we're kind of adjusting the amplitude of the wave. This knob here, the multiply, essentially is doing a phase control. So it's kind of repositioning the wave. Then we have gain, which is another, obviously, an amplitude control. The combination of all these things will change what you get. Which waveform you send out will change what you get. Above the outputs, so this one thing to know on this system here, these black circles are outputs. These are coming out. The hollow circles are inputs for something called control voltage, which, like we said before, is when we apply another frequency to one frequency to another one to do things to it. So if I have this and I send it control voltage to the pedestal, see it's hitting all the things, but let's send it like that. So as I do this, I'm adjusting the pedestal of this with this.
Wait. Can you repeat that? Sorry. You're adjusting
Yeah, so we're outputting from here.
from here?
Think about the signal path that we did, like this is what modular's all about. It's like what's going into what and where is that going out. We're outputting this triangle waveform from the voltage controlled oscillator into the luminance channel on the mixer. This is like a little mixer basically. And then we're adjusting its pedestal control, its voltage control of its pedestal. We're basically like electronically moving this knob with this oscillator.
So the out of the second oscillator is controlling.
It's
the
controlling the
Oh,
pedestal
I
control of
see.
that.
Okay, it's
And then
controlling
you
the
see
pedestal
this
of
one.
that one,
You
okay.
see this because this is only outputting.
And those are just three identical oscillators. You can do stuff. You could
Well, there's two oscillators. This is actually something else. Which we'll
Oh,
get
two.
to
So
later.
two.
It's
You
different.
could put them like stack them or sequence
Yeah,
them.
yeah. You can like, because the outputs are independent of each other. I mean, like, you know, the oscillator, like,
It's 'cause you
they're
can
not
view
tied
that.
together. So like, I could output this oscillator to here, but then like output this, you know, the square wave to that. You know what I mean? Like the components are not just discretely like have one output. They have multiple outputs, and the outputs can go however you route them.
So what are you adjusting the pedestal? What level here are you messing
If
the?
I change the frequency of this oscillator, it's affecting the pedestal of this one, because I have sent it the output of its sine wave into the pedestal voltage control.
And it's not dependent on which of those outputs. the
It's
reg-
somewhat. I mean, it'll change the shape somewhat. So if I do it on the frequency, let's see it.
So the
more.
inputs are contingent upon a specific parameter like frequency or pedestal, but the outputs.
Well, I mean, if you change the frequency, you'll see a different output.
Right, but these outputs down here, are they controlling?
These are outputs, and these are inputs. Same here.
But if you
If I
have,
put an output into an input, then the output controls the input, controls this. So it, by default, it's controlling what you see on its output. Does that make sense?
And you could output with a different waveform than a sine wave. Is that right? On the second
Yeah,
oscillator.
yeah. I
yeah,
could send it.
that's what I'm gonna,
It's actually sending it a triangle wave right now.
Oh, so that's my question. So
Yeah.
those outputs are the different wave
Yeah.
types.
Waves.
Wave types.
Yeah,
So
yeah,
you
yeah.
can
Can you? I don't know if you guys can see it. Maybe you gotta get, maybe you get closer. It's fairly small print, so
so this is
you
the,
might be part of it. See the square wave up here?
yeah,
Yeah. Okay, cool.
And then you have a triangle wave, and then you have variations of a sine wave there. And same
so
here.
there will be some changes.
Yeah. Okay.
I'm putting it into the multiply control right now as I shuffle. If I change the multiply on the one I'm affecting, you're going to see a difference. If I change it on here, you're going to see a difference. So it's a relationship. Everything's about relationships between the two. One affects the other if I've wired it that way, you know?
The oscillator is just like a little engine that's going no matter what. You don't need to give it an input. It's just kind of.
Yeah. I mean, it's kind of going
Yeah.
Oh, you
at a
don't
rate.
need to give
That's what I
it
think. I don't have that in the mixer.
No. I mean, the only oscillator you have is your probably your like tone generator.
Right.
Yeah, that's what.
What do you mean you don't need an input?
You could have,
Because
Yeah.
he set up the second oscillator to just be operating on something else. He's not sending it. He's not sending anything.
There's
into
no
it.
video coming into this. It's generating it with waveforms. This is what synthesis is about.
Okay, so that's generating that diamond
Mm-hmm.
frequency.
This is
Oh,
everything we're
okay.
seeing here is being generated by the hardware that's inside the oscillators that are inside this machine. There's no other video image that we're manipulating, although we could if we wanted
we
to.
could, right?
We can send a video image into it. And probably with what we have here, it's not the most exciting use of it, but it definitely has its place, and you can do it and probably make it interesting. I don't want to even say that. I'm not going to say it's not. It's because it really could be interesting. So it's not really a fair statement.
It must have to spend tons of time and maybe a little bit of like hallucinogenics or something just to.
And if I change this cut here, I also have a video mixer. I have a colorizer and mixer. So this mixer has modes. We have a multiply, an additive, and I don't know what this middle one. I guess it's neither one or the other.
Oh.
So you know,
That's like a
this is how it's layering.
Yeah.
So we've got two channels here, just like we have A and B in this guy here. We got A and B here, and they're labeled A and B. You got A here, and you got B row here. They each have the same number of inputs. They got a red, green, and blue, and a luminance input. So
Oh,
I
A
can
and
send
B.
oscillators to just the red input. I can send an oscillator just to the blue input, and I can adjust. I can alter the blue levels of the video image by how I position these
Which one?
pots, and how I position this frequency, and which channel I decide to bring up. the malleability of a system like this is basically infinite. That's the point of why you even do it. Because you don't know exactly what you're going to get. You kind of have a path that you're going towards, and then things start revealing themselves as you're doing it. Like I wouldn't have known that I might necessarily get these colors this moment. I mean, I know I would get kind of that shape. I know, like I can break it down and say, you know, I have this oscillator doing this to the multiplication, so I know I'm going to get kind of a grid thing, but it depends on how I pull the gain knob, you know, how I clip the thing. So these combinations, just like know that they're like infinite. You're going to stumble on a lot of things. The point of a system like this is very much experimentation.
So, and can you bring like, say like you're filming something?
That's unsynced. You can lower you can get to the rate to something where it's kind of rolling.
So like say you're filming something in here.
Mm-hmm.
Like I know this is generating its own like imagery. Can you have what you're filming interact with this?
You can definitely colorize it with this and automate the colorization. Yeah.
Oh, okay.
Yeah.
But you can't like bring these crazy patterns in or something.
Yeah.
Like a background, for instance, for a chroma key, this as a.
I mean, you
right?
could, you would probably want to do that through a mixer, like depending on what you want to do with it. I mean, it's not going to like, if you want to layer them effectively, you would bring your video into, you could bring your video into here, colorize it, output it, through one output, but you know, yeah, I mean, it just depends on how you combine it. I mean, I don't know exactly what you're meaning you want to do, but if you want to like layer these patterns over it, for example, you probably would want to use 2 independent channels in a mixer.
Yeah, or like I guess what I'm wondering, like, okay, say like it's an image of, you know, like say Matthew right here that I'm filming. Like, could I twist the image the way you're using this machine, the way it's currently manipulating?
Could you
what
take
it's
the image and like
generating.
make it like scroll and do this stuff?
Yeah,
like move the image?
yeah,
No.
like stuff
no.
like that.
No, that's
Or-
what you cannot do, and I'll
Okay.
explain to you why. And that's why I showed you guys some of the stuff earlier, actually, partly. Raster manipulation is not the same thing. There are ways to do things kind of like that, which I'm trying to get them to get like a vector scope. What that would be like sending the image, and this module is actually quite useful for it. You have to send the image into the luminance channel, send ramps out from here to control the horizontal and vertical positioning, and then send them out to another display. And you would have a monochromatic image of it. Think of an oscilloscope. You guys ever see oscilloscopes? You wouldn't use an oscilloscope, but you would use something called an XY display, which is like it's a raster display. So it doesn't produce video, but it moves light in an XY positioning across the screen. Some early video games use them, like I think maybe Asteroids. What was the game where you had like the lines, the spaceship? Yeah, like early video game. Pong. I think Pong might have been video, but yeah, ones that kind of they're using a raster display is where it's moving a positioning of a light beam across the screen instead of like generating a video image and working it that way. So if you do those kinds of things, you can rephotograph them and then like reprocess them through a mixer and stuff, and you can that's when you can start like warping
Okay.
images with like oscillators and things like that without using a digital process like this.
Okay.
So that's getting a very complicated and in-depth answer to
Yeah.
what you're
I,
asking
like,
me. But
think
no,
I know
you
what
can't
you're
just like
saying,
put
but
video in
yeah.
here and then like stick an oscillator on it and make it like wobble the video. Not
Yeah.
in that, no.
Yeah.
Not
You
like
key
this.
the oscillator
Like
on
the-
top of the video in the mixer.
You could key the oscillator on top of it. You'll see a picture of it keyed on top of the live video. Yeah.
So just jumping off of that, the video.
I'd love to be doing raster stuff in here too, but that's like I can't move the raster display every week. If we can get one in here one day, you could do it with this. I do it with this system.
Just with the all fall and you know, the
Yeah.
explain how that was done. That was layering, as you said. That was like.
He did a lot of. I mean, he even he was saying he did his stuff on Mylar,
Yeah.
reflections on Mylar.
So that yeah. So it's more-
Rephotographing. They did use. I mean, I saw a wobulator in there, so they were doing some raster. He said rasters, but they did some raster imaging. Yeah.
But they were also mixing stuff down.
Mm-hmm.
Yeah.
Yeah, keying in the mixer. I mean, combining processes is kind of what it's about, you know, and that's like where it gets fun. Stacking things on top of each other, having the ability to key on top of other things.
And when you were using the words in the video that you showed us, were you using?
No, I did that on something called a wobulator, but I was using a similar idea. Like I was manipulating the television display with oscillators. They just weren't these oscillators. They were Eurorack Deptford oscillators, audio oscillators.
Was that a performance then, meaning that that video is unreplicable?
Yeah, I mean, all that stuff's like not. You got to record it. You can't
So
do it
that's a
again.
recording. That's what
Or like
I'm
the
saying.
one I showed you with like, I mean, I think there's thousands of these like clips and videos stuff, but like the one I showed you with like the thing going like the shape that was like
The beginning.
through the like and then back down was like one layer was this synthesizer outputting a circular kind of shape, but being modulated by other oscillators connected to a surge audio synthesizer, and then the shape that was actually going through the stuff was the same signal sent to a raster display being rephotographed, but it defocused the camera. So
So you
it
could
just looked like a
never
blob.
re-access.
You couldn't see the shape.
So
you
you
couldn't
don't
see the
make-
lines. You could just see a blob. And then that was being positioned by other oscillators. So all the things were being, and then they're all being mixed down into a colorizing system.
But you can never re-access that video. You
I
know,
can never
you have to
recreate that video the
re-perform it,
same
yeah.
exact
But
way
what if
ever
you're just
again,
using,
no.
say we're just using this setup, could you not make like a chart of all of the
Yeah, you could try
settings
to.
here?
You probably would get close. Probably wouldn't get it exactly the same. I mean, you probably, if you sat there for long, you probably get it close enough to be like what you want to do. If you got all, you know, anything that was connected and you had the right positioning on the dials, I guess, you know, yeah,
It's like Abbey Road for the video.
it would be, you get close.
Yeah.
You know, it's a pretty stable system, for sure.
You would have to map out.
There's more modules to look at. It's not even scratching the surface. Really.
But you could just go out of the monitor into a deck and just
To give us a show.
keep recording.
Okay, so we have like really little bit of patching going on here. We could do a lot of other things to it. Who knows if they're gonna, so these cables too, by the way, these are stackable cables, which means that like you can put a signal in, and then like just go into the cable and add another signal on top of it. They are useful for getting one signal out to multiple places. This does the same thing. It's called a multiple. The way this works is top down, so one thing goes in there, and then a copy comes out of there. So if you put something in here, you get the same thing out of there, and you get the same thing out of there. And then when a new circle starts, it's like another bank. So you could loop this one into that one and then duplicate and duplicate, or you can just send something else. So this just gives you copies of your signal. Sometimes you really need that. This will also do that, but you only get, you get one on each end. This kind of works the same way, but it allows you to kind of blend signals in a way more easily than this does. Like this works well for like, I put something in and I get two other ones of it out, two copies of it out. But this I could like put it in here, and then like I want to like stack two. I don't want to use another oscillator to like control a parameter of something, but I want to just like combine the two waveforms together and then take the package and do something with it. So they're useful for that. It's called a stackable cable.
Could you also stack it? Like, could you just keep stacking?
You can to some. I mean, you can't go in forever. Then you start like, you lose bandwidth in the signal, and it starts to like not work so hot with interference and stuff.
Do they have the BNR cable or what's it?
BNC?
BNC cables.
No,
for that?
this is like a mono mini jack. The Eurorack system. There's other systems for modular video, but Eurorack is what is
But
being
this is
used
not
now the most because Eurorack audio took off. So Eurorack video is kind of following suit.
But how would you stack signals like from here or here?
Well, you wouldn't be able to stack like this directly into this, obviously, because it doesn't fit. What you could do, I mean, the way this is designed, technically the signals will mix. If you can find a way to get an adapter to it, they will kind of like work with each other, but you're not going to probably get the results that you want. If you want to get video into the system and like do things, colorizations of the video or with the oscillators, the best way to do it is to go in to this Cortex. If you took a VNC cable though and put, do I have any with me? I might not. there are, I might have them in the case.
What's a BNC cable?
BNC is the video cables that we're
Oh,
using
that
for
one,
most of
yeah,
the stuff.
yeah.
The professional version of composite cable. There is this, which is answering your question. It's a BNC to mini jack adapter. So yeah, you could bring video into like a key, or which we didn't get to the key yet. There's a lot of things. And sometimes it'll work better than others, but it's definitely worth trying out. So this is a keying section here. So if I take, let's just do something different here. Let's take, okay, so let's start with this actually. This thing is called the staircase, the LDX staircase. It's a frequency multiplier. So it's taking the frequency and multiplying the frequency exponentially. So you'll see that if I take this, this is a horizontal and vertical ramp output. These ramps, let's just look at a ramp first. Okay. Frequency's all the way down. As I pull this frequency knob up, we have this circle starting to develop, right? The circle is happening because this ramp generator section here, I'm sending horizontal and vertical ramps, so the two opposing shapes are making, in this case, this function generator is rounding them off to be a circle. It could be a diamond, it could be a different kind of diamond. You have to mirror it, it could be like a slope. So we have these variations already here up in the ramp generator. And it depends on if we send it, you know, horizontal plus vertical or horizontal minus vertical. We get an inversion of that. We just send it to horizontal, we get that. We send it to vertical, we'll get something like that. Makes sense? So if I combine this and this, I'm getting that. If I take it away, I'm getting that. Clear it out the middle. It's kind of this like just geometric kind of process. These ramps are like gradations or slopes. It's a waveform.
And
They're
when
be proved to be very useful though in generating shapes.
you have
So we're going to start with the horizontal plus vertical. So we have like the basic circle shape or diamond shape or whatever. So use this H plus V jack. Now I could put that straight into the mixer like that. And I just see it here, and depending on how I adjust the colorizer and how it's layering the coloring, see if I have these set where I want to do them, I get like, you know, different kinds of shapes and gradations. Red ball happening there. Okay, so that's if we go straight in. But like say I want to not go straight in, say I go through this multiplier, so I go into the source input. Remember, hollow circles are inputs, usually they're above, and the dark circles are outputs. So I'm putting into the source because I want to like give it something. So I'm going to give it, that was a mistake, see, I want to put it actually in the ramp generator. I have to output something. The source here, and then now this device here has got 3 outputs on the bottom here. You see by 1, by 2, by 4. They're just incremental layering of the signal. And then this top level here is it's harmonics of the signal, so iterations of the wave, let's say, to some kind of proportional amount. So we take this, we'll say we'll start with, we'll just go do the 2 out.
Is there a difference in the color of the cable? I mean, there is a difference. Does it mean anything?
No, not at all. It's
Okay.
they're
just
all
need
the
to
same.
find
Yeah. Yeah, I mean, I don't know why I have all these wacky colors. Probably better practice. But okay, so I have that circle. I have the frequency all the way down. So I bring the frequency up. We have the ball where we had it, but now we've got one inside the other one, and then another one, and then another one. So it's doing kind of harmonics of or multiplication of the wave. So this lets you do these kinds of really cool concentric kinds of effects that happen. And as I shift these harmonics, it changes like. I mean, actually, I don't even like completely. You know, as I'm not a modular synth designer, I don't even. This is going past like my level of understanding as to why it's doing what it's doing, but I can show you what it's doing.
Well, harmonics would
split.
be like the ratio.
Yeah, I just
Right.
don't know,
3,
like, I don't
5
know
or
how
It's
the
like in
relationship.
music, right?
5, 9 or
In
whatever.
Yeah,
music.
I don't know how they've stacked. I mean, I can see that it's an incremental increase here, and then you can add them on top of each other. So, how these are positioned will change what you get. That much I can tell you. I can't tell you like, exactly like how the electronics are working or anything. The phase adjustment just changes. Like phase does changes the positioning of the waveform where it is and where it starts and ends. So it moves the whole thing over. It moves the whole thing this way. You can see that pretty clearly. We have it coming out into this color to the luminance channel. So if we pull the red up or red down, you see that. If you pull the green up, we see green. If you pull the blue up, we see blue. We could. It's very garish looking right now, but pull this green. We could take another output and put it into red on that side. We've turned both mixing channels on. We turn it off, we don't see it. So up is on, down is off. I mean, you're gonna basically just want to experiment with stuff. But
So
kind of
what
walk
was the
through.
second one that you put? It was controlling. Here, this one is controlling.
I've output another output from the multiplier
Uh-huh.
with the same input, and I put it into red channel on
Oh,
feed.
negative.
So
Okay,
it's a mix of the
negative
two.
color. Okay.
I put it into this voltage control. Well, I won't really see much in this case actually, so much once I shift this, the way they're layered. But these combinations basically just produce different results. And if I negative it, if this very like happens to be with my color positioning, I have this very like candy shop looking kind of thing. So we do that, and then we could say go into the frequency adjustment. This is controlling the how many of these. Oh well, look at what happened there. It's the fun parts about analog when like you don't finish patching and like some
And it's already
interference has gotten
starting.
through, you know. Oh, what's that?
Whoa. And what happens when you touch the tip? Just touch
Yeah,
it?
I mean, there's like some kind of electricity that's being conducted
Electricity.
through the cable. So you know, this is why it's fun, guys. I wouldn't have expected that necessarily to happen just now.
So wait, a quick question here. When you were tweaking that divided by 1, divided by 2 knob, and you get more or less circles going
The
on,
frequency-
that
the
was a
frequency knob.
performance thing on your part, right?
Yeah, yeah, it's
Can you
happening in
assign
real
a
time.
like a voltage controlled oscillator
That's what I'm
to
about to
that
do.
work for you? Okay, thank you.
This is why I started patch. So I'm going to frequency voltage control, and I could, let's send it to LFO, a low frequency oscillator. And does anybody want to guess what's going to happen if I send it in an LFO? Yeah, I mean, yeah, the LFO is pulsating. It's sending out an oscillation, but it's at a lower frequency than these voltage controlled oscillators. So it's going to shift the parameters of this dial, depending on where this dial is positioned, over time. So it'll animate it, basically, for lack of a better word. The thing is really fast right now, so we're going to slow it down. These mode switches go into like normal and then like really fast.
Hyperdrive.
Yeah, hyperdrive. This is just, I'm just adjusting the frequency. If it's sitting there, it's going to go in, and it's going to come back out.
Are you controlling
it's
the
gonna-
in and the out, or no? It's just the way the frequency.
I am by how I position it, like what I tell it to do, but I don't have to sit there. It's like
Uh-huh.
imagine a piece of electricity turning a knob for you.
But I would think there would be a constant out or a constant in, and
There
this
is.
is pulsating out and in and out and in.
Yeah, well, the wave
Because
goes
it's the
up and then the wave
frequency
comes
of-
down.
I see.
So you reach the
Sorry.
peak of the wave, the crest of the wave, and then you reach
And
the
then you
trough,
go
and then you
up.
reach the crest, and then you reach the trough. It's just happening at a slower rate than.
So could you put another one on top of that that randomizes the rate at which you're tweaking, you're manipulating
To drive control voltage the LFO.
Yeah.
On this LFO, you can't control voltage the LFO, but you probably could do this, where you took a stackable cable, and yes, you could do something where you controlled the rate because you would be doing what I just did, and then you would stick something else into the cable. So if I send it, anything we want, let's send it the output of the same thing. We're gonna get feedback.
Oh, yeah.
If we don't send it the output of the same thing, that's why we get this kind of like crackly looking stuff, because it's feeding back. We can send it to this one. And we get that.
that's gonna be
So I feel like you guys are getting the idea because you're asking all the right questions. You're asking all the right questions. But this is what it's about,
It's
you
gonna
know.
be a very psychedelic.
Yeah, I mean it can get very
So there's all
psychedelic.
these creative decisions about what do I want to performatize versus what do I want to oscillize.
oscillate. Well, yeah. I mean, what do you want to automate?
Yeah.
Yeah. And
Well,
what?
Oscillation could also be part of, like, going back and forth between oscillating something and not. Like, that could,
Right, you could oscillate the performer,
you
the
can
choice.
compose anything.
Yeah.
Okay.
Stop daisy, stop stacking on top of the stack.
And then we have this, and then you know, we can control the phase of it, positioning. So I says, all right, well, yeah, we can start with let's touch the navigator actually. 1 second. Okay, so this thing is an XY positioner and rotation module. We can essentially send anything into what it reads as horizontal and what it reads as vertical, but starting off the bat, we'll just send it the horizontal and vertical ramp and keep them in line with what they're supposed to be. You don't have to do that at all. Not want to at all. So if we take this positioner and we output let's try something here. See what happens. Control the phase with a XY positioner. We notice something different already, right? You see something with the color change?
Yeah.
If I rotate this and change, I'm oscillating the phase of the signal. This is basically going in a 360-degree rotation, so you can use it to oscillate colors. If I put it into the voltage control and do this, I'm controlling the way it's layering the video right now.
Is there a sync option with the phaser?
Is there a sync option with?
In the same way there was with the.
You can control the rotation. Yeah, you can
Okay.
you can voltage control the level of rotation, kind of like its frequency, where it's going. You can modulate what happens to X and Y. So put something else into X positioner and send it a waveform and bring it over. Oh wait, we're not, because we're not sending it It's getting a bit stacked and stuff, but yeah, so this rate, if I shift this, is changing. See these lights going around? This is how fast it's rotating in a 360 degree, or in a kind of like one of these kind of this, or what do you call it? An infinity kind of symbol?
Yeah.
Like an inverted
Figure eight.
loop. Like yeah, figure eight. Thank you. Figure eight is the term I was looking for. Exactly. 360 and like it says times 8. It's like a figure 8. So this is a rate of rotation, and you can apply this. So you can apply this stuff to, how the red moves, for example, or it should at least control that. Maybe I have the wrong symbol on it. Oh yeah, here we go. So these can be used to animate lots of things. I mean, it can animate. I have it going into the color, but I could send it into something else, like the phase if you're going to. I have to send something into the colorizer that we want to see anything. See how the shape is kind of acting differently? How it's like going in and then like going like that? It's because we're rotating we're basically
you're putting
electronically
harmonic.
rotating this phase control, and then if we change the positioning of it, it affects as well. If I change the rate, it's faster or slower in the other way. If I send it vertical, you see it looks slightly different. You can, so I mean, these combinations are kind of infinite. Another thing we have here is a audio filter. We could send it, let's see, let's put a horizontal vertical ramp. And the input of the audio filter here. So the audio filter is, there's a band pass, a low pass, and a high pass filter. It's kind of just taking a waveform and clipping out elements of it, or squashing elements of it, or filtering out elements of the wave. And depending on where you position the knobs is depending on what you're going to get. The audio filters can be useful for adding a complexity to the contours of shapes a lot of time, where if you give it like a circle kind of shape, you might get something where you can break it apart and make it more oblong, add distortion to it. You can control voltage of the filter itself, so you could send an oscillator to the filter and change how it behaves. All this stuff can affect each other, is the point. Except the LFO for some reason is a snap. So, put it like that, I'll try the bandpass filter out. Send it to this colorizer.
Are there actual numbers or like metrics on the dials when you're doing the band pass and the low pass, high pass, or does it not really matter?
It's not really numbers, it's just like left or right positioning. Getting too interesting with that. So if I kind of like get it into the right zone and like tweak it, see how like I'm kind of like contouring this shape where it's like that a little bit and there's like elements of distortion. And this is just like how I'm messing with the filter. So the filter is kind of like used creatively. I mean, we're using something designed for audio, but to add variations and stuff to our shapes. And, you have controls of like positioning of the filter, the resonance. This one has a resonance control. There is the input level itself, so how hot it's coming into the filter, like how much it's getting the signal. Then there's an attenuator, which I guess you only kind of like, you see the results depending on where the input is. Then there are these like other switches which they're labeled kind of oddly. They call it character. I don't really know what they mean by that, but they do things to it.
Are you getting that notch because you're using the band pass setting?
Yeah,
That way?
yeah. If I dial things back a bit, see like I can get more bars in there.
You said this was an audio signal?
No, it's just an
No.
audio filter, but
Oh,
it'll take,
okay.
we can center frequencies and manipulate it with it.
And is the is the audio filter, that's where you're plugging it in, or is it the type of cord you're using?
No, it doesn't matter. I don't want to like make people like confused because I say it's an audio filter. It just happens to be an audio filter, but it doesn't really matter that it's just we're able to
Just
use
what
an
it
audio
does.
filter to
Oh, okay.
manipulate the waveform. There's no audio. We're not hearing any audio right now. That's for sure.
Does that mean other audio filters could be patched into like a graphic EQ or something if you had one, or would that work?
If you can get mini jack output from it, I don't know what you would get. Like I don't know you would get a control. You wouldn't get a control voltage. Like you wouldn't be outputting a control voltage, so you wouldn't be
Oh right, because it's
changing anything. You might be able to take that signal somehow and route it somewhere, and like you might be able to mess with that signal
but there's not a
with
proper
other
signal
stuff on top of it, but you wouldn't be able to use that signal. I mean, hell, I don't know. It might happen. Something might happen. Like that's the kind of thing with this. Like you could try it. I don't think the results of that would be pretty unpredictable. You know, they wouldn't be able to say like, oh, I can see that I'm applying like this control voltage to that oscillator, and I know I'm going to get something kind of like that. You know?
It's amazing how much of the.
What? How are we on time right now?
It's been 80 minutes.
8:30. So
Okay, stop.
yeah, those are.
Oh,
Oh, well,
okay.
there is. Okay, so let's go clear some of this stuff out.
I know, I'm kind of wondering about that too.
Get back to something which is simpler. One other thing you've got in here.
Apple's
take
like, that's
the-
fine, keep recording, I'll just charge you.
So we'll take the same ramp output and go to the multiplier again. We're going to put the multiplier, instead of putting it right into the colorizer, we're going to put it into the keyer. When we put it into the keyer is hardwired already to the switcher, but doesn't mean you have to stick with the way it is. So the keyer is doing kind of what the Luma keyer does in here, but it's using the waveform as the shape generator. So that shape now is keying out. We can key inverse out. This we don't really see it because we're in the middle position. So say we put it there. We can control the rate of change with this fader between A and B, nothing's in B. We cycle it. If we put it on cycle, it's going to keep oscillating between whatever positions you have it here. So if I bring it there, it's
Without
gonna
having to.
so then we have the control the speed of it with the fall and the rise. controls, and these are these interdependent controls which have a relationship to each other. Like with one's here and one's there, it's going to go at a different speed. We can take this output, that key, and put it into another color, and then we get a different way of color mixing. We can take that output and put it into a filter. And I'm just trying stuff out right now. And kind of invert it on itself and change the colorization or change the filter and get different kinds of results.
Jeez, this is endless.
Yeah, it is
Really
pretty
endless.
endless actually. I mean, there really is pretty much endless possibilities with something like this. Like for layering signals on top of each other, essentially it's endless until you run out of places to plug things in or modules. Um,
Is there a point at which this system, I mean, aside from literally you've patched every single hole, is there a point at some point where like it just can't? Have you ever maxed it out?
No. I mean, it didn't stop working. That's no. No, it won't stop working. Just get something. As long as you have something going into the mixing, yeah. I mean, signals may cancel each other out to some degree, but something will go through.
So let's say I'm actually not a student in your class.
Kind of hideous looking. But
Let's say let's say I love this, and
Okay.
I'm an experimental animator, and I want to use this actual video signal in an HD video project that I'm editing in After Effects. How do I get this? Do I
well,
have
it's
to
coming in the switcher
It's
right
coming
now.
there, you
Oh,
can
it's already
use-
coming off.
Right.
If you look on channel 17, it's going into the studio.
So you can record it to a hard drive.
Yeah, yeah.
Okay.
Unfortunately, the only thing is it's scaling it up to the switcher, so
Okay.
if you're going to get it in